So I'm going to draw triangle ABC and label this point A, this point B, and this point C. And I'm sure many of you are familiar with the sine law. The sine law states that A over sine of A is equal to B over sine of B is equal to C over sine of C, where the lowercase letter indicates the side opposite to the angle. So A, B, C. And the capital is where the letter is. So angle A, angle B, and angle C. But the thing that some of you might not know is the extended sine law, which states that A over sine of A is equal to B over sine of B is equal to C over the sine of C, which is also equal to 2R. Now, I'm sure you're wondering what R is. So, if I have a triangle right here, a circumcircle is the circle that encloses the triangle while including all 3 points. Now, that's not perfect, but I'm pretty sure you get the point. And so basically, the value of R is equal to the radius of this circumcircle. And so, for example, if I draw the circumcircle of this triangle, it is true that A over the sine of A is equal to B over the sine of B is equal to C over the sine of C is equal to 2 times the radius of this triangle's circumcircle. Alright, now let's get into the proof of this statement. So let's say we have a triangle inscribed in the circle over here. Let's label it the points A, B, and C, and let's label the center as O. Now, let's draw a line perpendicular to BC passing through O. So here, and we're going to label the intersection D. Now, since this is a circle, BD is equal to CAD. You can prove this by showing that BOD is congruent to COD. And so now let's connect line BO. Let's consider angle BOD. Now, the sine of BOD is equal to the opposite over the hypotenuse. Now the opposite is equal to BD, while the hypotenuse is equal to BO. So the sine of BOD is equal to BD over BO. But we know that BD is equal to A over 2, because as I mentioned earlier, D is the midpoint of BC. And now we also know that BO is a radius, because O is the center of the circle and B lies on the circle. And so we have the sine of BOD is equal to A over 2 over R. And this is also equal to A over 2R. It can also be shown that angle A is equal to BOD. So we have the sine of A is equal to A over 2R. And so we have the sine of A is equal to A over 2R. Then we can rearrange to get that 2R is equal to A over the sine. And so applying the same logic to B and C, we are now done. And now, using the extended sine law, I'm going to show you a new way you can find the area of a triangle. Now, let's first draw a line perpendicular to BC that passes through point A. So, the altitude from A, we're going to call this point D. So now, the area that we are looking for is equal to 1 over 2 BC times AD, or 1 over 2 base times height. But we're calling BC A, so actually the area is equal to 1 over 2 times AD. Let's call angle ACD theta. So now, what is the value of the sine of theta? The sine of theta is equal to AD over B, because the sine is equal to the opposite over the hypotenuse, and the hypotenuse is equal to B. And so AD is equal to B times the sine of theta. Now we can substitute B times sine of theta into AD up here. So we get 1 over 2 times A times B sine theta. Now actually this angle is angle C, so by the extended sine law we know that C over the sine of C is equal to 2R. And so we can rearrange to get to that C over 2R is equal to the sine of C. Now substituting C over 2R into the sine of theta, we get that 1 over 2 times A times B times C over 2R is equal to the area. And so multiplying all these terms together, we get that ABC over 4R is our area. And so this is a very useful way of finding the area of a triangle when you know all 3 sides and its circumradius. And so, just as a little note, I'm going to show you 5 ways to find the area of a triangle. So the first way is probably the way you use the most often, which is base times height over 2. The second way is using Heron's formula, which you might know as the square root of s times s minus a times s minus b times s minus c, where s is the semiperimeter of a triangle, so s is equal to a plus b plus c over 2. And the third way is to use a sine, so either 1 over 2 bc times the sine of a, or 1 over 2 ac times the sine of b, or 1 over 2 ab times the sine of c. All three of these are really just the same formula. And now the fourth way is using an inradius. So you might be more familiar with this formula. It's equal to the semiperimeter times the radius, and that's it. Now the inradius is not to be confused with the circumradius, where the inradius is a circle inscribed in a triangle, while the circumradius is a triangle inscribed in a circle. So the last way is ABC over 4R, using the extended law of sines. And now these are the 5 main ways to find the area of a triangle. Alright, now on to some problems. Alright, now the first problem is above the board. So I've already drawn out a diagram of all the points and circles. So first we know that xz is equal to 13, we know that oz is equal to 11, and yz is equal to 7. We also know that ox and oy are radii of circle O. So we're going to call these lowercase r. We also know that the center of this circle to x and the center of this circle to y, these are the radii of the big circle, so capital R and capital R. So now we're going to apply the extended sine law. You see, since these two triangles are in the same circle and are also inscribed within the same circle, the ratio between a side length and an angle is always the same, all of them being equal to 2r. And so that implies that the sine of xzo is equal to the sine of ozy. And since both of these angles are lesser than 90 degrees, we can also state that the cosine of xzo is equal to the cosine of ozy. So let's call this value x. So now let's apply cosine law to these two triangles. So we know that r squared is equal to 13 squared plus 11 squared minus 2 times 13 times 11 times x. We also know that r squared is equal to 11 squared plus 7 squared minus 2 times 11 times 7 times x. And now, multiplying the terms out in these brackets, we get that 13 times 11 is equal to 143, and also that 11 times 7 is equal to 77. Now, multiplying both by 2, we get that 2 times 143 is equal to 286, and 2 times 77 is equal to 154. So 286x here and 154x. And also adding 13 squared and 11 squared gives us 290, and adding 11 squared and 7 squared gives us 170. And so now we can set these two equations equal to each other, since both are equal to r squared. So 290 minus 286x is equal to 170 minus 154x. Now, this is equal to 120, and this is equal to 132x. So x is equal to 120 over 132, which is also equal to 10 over 11. Now, substituting 10 over 11 into the equation 2 gives us 10 over 11 times 154, which is equal to 10 times 14, which is equal to 140. So we have r squared is equal to 170 minus 140. Now, r squared is then equal to 30, and so r is equal to the square root of 30, and that is our answer. And so we are done. Now, using sine law, we are able to determine that the cosine of xzo is equal to the cosine of ozy, which allows us to solve this problem. Alright, thanks for watching, hopefully you enjoyed, and hopefully I'll see you next time.